Lesson 6.2, now we're talking about scale diagrams and reductions. Now we're going to shrink them and reduce them. We're using the exact same equation, only now this time, if you take a look at the bottom, when you're reading this over, we need to now have a decimal that is, this tells me it's got to be between 0 and 1. So the decimal's got to be between 0 and 1, which means it's got to be a small number, okay? Let's take a look at what a couple examples are going to show us here. First one, it says draw our shapes and label our sides. Okay, so we've got our shapes drawn, we're going to label our sides. If we count all these, we get 10. Count the side here. I'm going to get 6. Okay, it says we're going to decrease by a scale factor of 1/2. If I've got a scale factor of 1/2, what am I going to do to each of those numbers? Half them, exactly. So I half them, meaning divide them by 2. So if I cut 10 in half, what do I get? 5. So my new diagram's got to have a 5. So again, we can overlap them. 1, 2, 3, 4, 5. There's my 5. And if I half 6, what do I get? 3. Good. 1, 2, 3. And then you go join the point to make diagonal triangle here. Make a diagonal line, join the two lines, and make a triangle. And label your new point. So that's going to be a 3 now. Our diamond, again, we've got diagonal lines. So there's only one way we can do this. Either make a line straight down the middle or across. So if I go straight down the middle, what do I get? 4. Good. So to make a reduction that's half that big, what am I going to do? Make it a 2. Good. So I'm just going to draw my middle line, make it a 2. Now again, that means my middle here has to also be a 2. So now I'm just going to connect the lines where I draw my plus sign. Now why is it a plus sign? My plus sign is just showing me that I've got 2 going left, 2 going right in my diamond. Okay, so 2 vertical, 2 horizontal. Whereas over on my bigger diamond, I had 4 vertical and 4 horizontal, 4 both ways. Okay, so we had to reduce it, and we get 2 and 2. Okay, pretty simple stuff so far? All right. Well, let's take a look at how we would do it with a circle. Circles don't have any edges. So what do you think we're going to have to do with a circle? You're on the right track. Diameter. Good. So we're going to go across the middle and find the diameter. Okay, so in a circle, use the diameter. Okay, so we're going to find the diameter here. Let me write our diameter down. How big is our diameter here, guys? 8. Good. Now take a look. Just count your lines here. So you got 1, 2, 3, 4, 5, 6, 7, 8. Oh. Okay. Over here, you're going to go across the same thing. You've got 1, 2. This guy becomes a 2. Now we want to make our scale factor. It says find the scale factor. So now we've got to write our equation. S equals D over A. This is our diagram because it's what we started with. This is the actual. Or sorry, other way around. Thank you. This is our actual we started with. This is the diagram what we ended up with. So my S equals my D 2 over A, which is 8. 2 over 8. Does that reduce the fraction? Yes, it reduces to how big? 1 over 4. Good. So it's 1/4. So this small little circle has reduced the big one, and it's become 1/4 the size. So if we had to put that in a decimal, what would you say? 0.25. 0.25. Good. So or 0.25. Excellent. Now we're going to get some problem-solving questions. They're not going to show us diagrams. They're just going to show us numbers. So let's take a look at the next question. Okay. Now it's talking about scale factors are sometimes written as a ratio with no units. If it's written as a ratio with no units, this is actually called the scale. Okay? And scales are always set up as D to A, always. Well, that's like our fraction. All they've done is they've turned their fraction over. Okay? Because our fraction is D over A. All they've done is they've kind of kicked it over that way and got D, A, and they turned the line into 2 dots. That's all they've done. Okay? It means the exact same thing. Now, it says these guys are used to shrink large objects so you can put them on paper. Okay? Now, the biggest thing we have to remember that is if no units are written, it's always centimeters. Always, always, always. Okay, so if there's no units written, they're always, always centimeters. Okay? All right. So it says, comparing 1 meter equals 100 centimeters. That's one of the unit conversions we have to remember. So we've got an object with a length of 50 meters. We're going to draw it to this scale. That's the scale we're using. Well, that means that this is our D, this is our A. So we're going to set up our cross multiply and divide. So first we're converting meters to centimeters, it tells us. So I've got my 50 meters, and I need to find centimeters. Well, right here it's telling me that 1 meter is 100. Well, what would 50 be then? 5,000. All you're doing is timesing it by 100. So you're going to get 5,000. Okay, so you get 5,000 centimeters. Now it tells us to set up our ratio. Our ratio is just our S equals D over A. Okay, that's what this is. S equals D over A. So we're going to set that guy up now. So now we've got our S. Our scale we know is 1 over 25 is equal to our D, which we don't know, but we know our A is 5,000 centimeters. Okay? Now we're able to find our unknown. We need to find our D here. We don't know what D is. Okay? So we need to cross multiply and divide, it tells us. So I'm going to take 5,000 times 1 and divide by 25. Okay? Now we're going to get a really big decimal answer. Now if we get you a big decimal answer, try and do it as a reduced fraction. Okay? So if I've got right now, I've got 5,000. What's that? Yes, it is. In this one, yes. It's the next question I'm actually thinking about. So this one gives you exactly 200. Okay? So I know on paper my diagram is going to be 200 centimeters long, and that's going to mean that it's 5 or 50 meters in real life. According to the scale they gave me at 125. 225 is what I mean. Okay? So that's how that one works. Let's take a look at the next question.
Wait.
Yes, I can. Okay, when problem solving, we need to compare sizes of our objects. We have to make sure that we have our units the same. That's one of our basic things we have to remember, because our actual real-life objects are usually in meters or larger. So, in this case, we've got a ship that has a length of 275 meters. So we need to change that meters into centimeters. How come? Because our diagram length on our page is always centimeters. So all we do is we take that number and times it by 100. That's going to give us how many centimeters it is. So I'm going to get 27,500 centimeters. It's going to be how much 275 meters is. Now I'm going to, it says determine our scale. So that just means we want the scale factor. Okay? Make sure you're writing this down, please. So we set up our equation. S equals, my diagram on paper is 25 centimeters. In real life, my ship was 27,500 centimeters. And all you do now is you divide them. If you divide them, you're going to get a big decimal. So it's going to be a run-on decimal. So if it doesn't tell you how to round, here it tells us how to round to 4 decimal places. So we're going to. But we're also going to find the lowest term fraction. So if I can put this into a lowest term fraction, what number should I divide by? Try 5. Sure. What other number would work? 25. See if they divide by 25. Do they both divide by 25? We know the top will, but does the bottom? Yes. How many times?
11,000.
1100. 1100.
No, it says 1,000.
Should get 1100.
That's the lowest. Oh, I put too many zeros.
You put too many zeros, yeah. So it should be 1 over 1,100. Now, again, it wants decimals though. It wants us to round to 4 decimal places. So, rounding to 4 decimal places, we should get 0.000. And then we're going to get 90 repeating. And then this number after here is a 0. So does the 0 make our 9 do anything? No. So my answer is just 0.0009. Okay? So again, if it's asking for decimals, I need to divide them and then round my decimals. If not, I do a lowest term fraction by dividing by a number they have in common to reduce it. Okay? Any questions on that so far? Pretty good so far? Okay, let's go to the next one. We've got a jet airplane now. It's telling us that it measures 25.4 meters off the ground. Is that my diagram or is that my real life? That's your real life. So this is my A value. But what do you notice A value is? It's in meters. So always check your A values. They can't be in meters. What do I have to do to them? Change them to centimeters. How do I do that? Times by 100. Good. So I'm going to times that guy by 100 first thing before I even start the question. So I get 2540. That's what you should end up with. Everybody give that a try. Okay. Now we're going to set it all up. The first question is asking us, well, what is our scale? Well, we can't find our scale out until we set up the equation. So we've got to set up our equation. We're finding S. So our diagram, I have to match height to height because it gives us two different numbers. It gives us height and a wingspan. If this guy is telling me height, I need to match the same value. So I need to match the same types of things. I'm going to match height to height. So that means that my 6.5 height of my diagram is going to match my height of my real life, which we've converted to centimeters, 2,540 centimeters. Okay? Divide that out. What do we get to 4 decimal places? Round to 4 decimal places, please. What are the other 2 numbers? I need 2 more numbers there. 26, good. Perfect. And then it says, what is the wingspan of the real jet airplane? Well, that's the scale we found out. Now we want to find wingspan. Well, we're just going to set up what's called the ratios. Okay, this is the equation. But if I've got more than one dimension of an object, here I've got height and now I've got wingspan. I've got 2 different dimensions. I'm going to set them up into dimension and dimension. So I'm going to set it up like this. So I'm going to go height equals wingspan. And I'm going to set my equation up like this. Well, I have 6.5 over my 2540. What is my wingspan on paper? 3.5. And I don't know my wingspan in real life. So I need to set it up this way. And then what do you think I'm going to have to do now? How would you solve that? I'm hearing somebody whisper it. Good. You cross multiply, then divide. So find the ones that are diagonally across. You multiply those ones. And we divide by the number left over. Okay? Give that a try. And solve for x, please. Solve for x, which is our actual length. Okay, our actual real life. How big is x? And it wants us to round to the nearest tenth, but don't round yet, because remember, we're still in centimeters. We're going to have to convert it back to meters. What'd you get for your multiplying? Yeah.
1,067.
Good. Okay, so 1,367 and 69. So now we need to convert that. Remember, that's centimeters. And we want the real life jet airplane. And real life jet airplane was in meters. So now I have to change that to meters. So how do I do that? If I go from meters to centimeters, I times by 100. What do I have to do this time? You divide by 100 this time. So now I'm going to divide this guy by 100. And all that really does is it moves our decimal place 2 points left, goes backwards. Okay, you just move your decimal point 2 backwards. You move it the number of zeros you see. 100 has 2 zeros, you move it 2 times to the back. So I'm going to get 13.6769, and now it wants me to round to a tenth. So what is that going to become? 13.7. It wants tenth. Tenth means 1 decimal place after. Okay, so you're going to round that to 13.7. Any questions so far? All right, moving on. Our next question asks us, how do you solve for a scale factor when they give you area? They're going to give you areas of 2 squares. Well, area we know is what? What kind of unit is area? Okay, length times width. What kind of unit? Squared units. So how would I get rid of a squared sign, do you think? What do we used to do to get rid of squared signs? Square roots. Good, you square root them. So let's see what it tells us to do. Here's our 2 steps. It tells us we square root both areas. Imagine that. So we square root both numbers. And that finds us our side. Okay, that gives us our side length. Then we set up our scale factor equation, or S equals D over A. Then we can use our new numbers, our side lengths, not the areas. So we have to find side first. We can't find area. Okay? Okay, you got a couple minutes to give this one a try. We have 2 different squares here. So the first step, square root both numbers. So root 36 is going to give me a side of 6. And root 324 is going to give me a side length of 18. Okay? So I've got both my side lengths. Now it's asking me for the scale factor of an enlargement. Okay, it's asking me for the enlargement. Well, if I know it's an enlargement, I need to set up my D over A. It doesn't tell me who D over A is, does it? But if it tells you it's an enlargement, what do you know which number has to go on top? The larger number goes on top. Good. So we've got S equals D over A, which means I'm going to have big over small because it's an enlargement. So I'm going to take 18 over 6, and I'm going to get 3. So that square grew 3 times bigger and became an area of 324. Okay? So the side length, we have an area of 6. A side length of 6. We multiplied all those by 3, and we got 18, 18, 18, 18. That's what it's telling us. Okay? We took this guy here, we times it by our scale factor of 3. Okay? Any questions on this? No? All right. This ends 6.2 scale diagrams and our reduction.